Hey guys, Mrs. Traver here. I'd like to do the notes with you for section 9.5, completing a square. So I have some things on our paper already for us to study. First off, I want to look at standard form of a quadratic and remind ourselves that this is that setup where it's ax squared plus bx plus c. And this is what I've been working with so far, but we're moving into a different format, which is vertex form. Looks a little bit different. You'll notice the h's and k's that are in there are going to later be shifts that show us the vertex. But what we're going to do today is kind of convert into vertex form. And before we had the solutions here, we were able to factor. But here we're going to find it a different way by what's called completing the square. So our goal is to set up these quadratics that right now are in standard form into something that will end up being a perfect square. So it'll be like something times itself, which we would have then set up to be a perfect square. So I'm looking for x plus something to give me, when I FOIL it, a 6x when they add, and then multiply to get c. So I want to figure out what that perfect c is. And how we'll do this is the only way I could have got a 6x when we add the same thing to itself would have been if I did a 3x plus a 3x. So this had to be a 3. And if that was a 3 there, then that made our c later when we FOILed had to be a 9. So notice a trend here. We cut 6 in half in order to get a 3x plus a 3x. And then we figured out what c would have been if we FOILed, which would have been 3 times 3 is 9. So we can use the same method here. 12 divided by 2 is 6. So this would have had to have been x plus 6. And then if I would have FOILed, I would have had 6 times 6 equals 36. So c equals 36. Oops, not 39, 36. So kind of our goal here is to find that perfect c so that we can then get it into a perfect trinomial. So this perfect square that we've been working with has a formula. So this perfect square, what we do is we take the middle term b, cut it in half, and then square it. So that'll be what we use when we find our perfect square. Let's do a couple problems where we convert into vertex form. All right, so number 1, say we have x squared plus 6x plus 8 equals 0. So I want to first give myself some room for my perfect square. So I'm going to move the 8 to the other side. And I'll leave myself a space there for my perfect square. So that's step 1. I'll put my steps on the right. So I want to make some room for my perfect square. It's going to go right here. And then let's figure out what that is. It is b over 2 quantity squared. So we're going to figure out that is this. In this case, it should be 6 over 2 quantity squared. So 6 divided by 2 is 3, squared is 9. So I'll say plus 9. And then the deal is when we add that 9 to the left side, we also have to be careful to add it to the right side as well, because we can't have an equation that's unbalanced. So we will add our perfect c squared to both sides. So I also have to add 9 to this side as well. That way everything stays even. All right. Now I've got some things happening on the left and on the right. On the left side, we need to factor. And on the right side, we need to simplify. So on my left, I now have x plus something squared, and that something is always going to be b divided by 2. Notice x plus 3, we would have x squared, x times 3 is 3x, x times 3 is 3x, gave me a 6x, and then 3 times 3 is 9. If I FOILed, it checks out. Over here, simplify, and I just have a 1. And then at this point, we are almost in vertex form, but our vertex form is set equal to like y, I should say. So I just want to move that 1 back to the other side. Move that 1 back to the other side. And then I've got y equals the quantity x plus 3 squared minus 1. So now we are in vertex form. All right, let's do one more like that. I'll skip writing all the steps for this one so it'll go by a little bit more quickly. So say we had x squared plus 4x equals negative 10. So first off, notice I've given myself space for my perfect square. So that's good. I want to add my perfect c to both sides. So I like to put a square there so I know that it goes on both sides. Ours will be 4 over 2 quantity squared. So 4 over 2 is 2. 2 squared is 4. So I need to do plus 4 to both sides. Now on my left, I can factor. It'll be x plus, cut this 4 in half, so x plus 2 quantity squared equals negative 6. And then let's move that 6 back over to the other side by adding it and throw my y equals in. All right, so without all of the business being talked about, it's not that long of a trip. Let's look at a different type of problem. These next ones we are going to be solving. So these ones we are converting. The next ones we're going to be solving. All right, so let's start ourselves off with the first one. We've got x squared minus 4x minus 21 equals 0. And we still want to set up our same situation, so let's give ourselves room for our perfect square. So I'm going to move my 21 to the other side. I'm going to add it to the other side. And now I have room for my perfect square to go. And that perfect square is going to be negative 4 divided by 2 quantity squared. So I've got negative 2 quantity squared. So I've got 4. Notice that this number that goes in here will always be positive because at the end we're squaring it and anything squared will be positive. So we'll do plus 4 to both sides. We had the same one twice in a row, I just realized. All right, on our left, we will factor. So x minus 2 quantity squared. And on our right, we will simplify, and we got 25. And now when we're solving, this is where we're being asked to do a different thing. So at this point, if we were trying to set it up into vertex form, we'd pretty much be done. If we're solving, we want to do a little bit more. So I want to get x by itself, and right now it's inside a squared. So I need to take the square root of both sides. And when I take the square root of the right side, I need to do a plus or minus sign to indicate that either it was going to be positive root 25 or negative root 25. So on my left, since there's a square root and a perfect square, it's just the inside, x minus 2. And on the right, I've got positive or negative root 25, and the square root of 25 is 5. So I've got positive or negative 5. Lastly, I can get x by itself by adding 2. When I added the 2 to the other side, notice I just set it in the front. And then at the very end here, notice because we have plus or minus, we can actually evaluate. The plus is 2 plus 5 is 7. The minus 2 minus 5 is negative 3. So I've got 2 answers there, and those are the solutions, aka the roots, aka the zeros, aka the x-intercepts of this quadratic. Let's do another one. We'll do 2 more. So say we had x squared plus 16x plus 59 equals 0. First thing to do is get yourself some space for your perfect square. So move that 59 over to the other side. and then do b over 2 quantity squared. So we've got 16 over 2 quantity squared. That's 8 squared. That's 64. So we need to add 64 to both sides. On my left, cut b in half. That's 8. So x plus 8 quantity squared. And on the right side, negative 59 plus 64 is 5. Let's square root both sides now to get that squared to go wrong. And when I square root on the right, I need to do a plus or minus sign. So on my left, I have x plus 8. And on my right, I have plus or minus the square root of 5. Lastly, subtract your 8 over to the other side. So I have x equals negative 8 plus or minus root 5. Now, unlike the last one, where I was actually able to evaluate because I got something nice over here when I took the square root, here I didn't. 5 can't be simplified. So my answer I can leave just like this. Either x is negative 8 plus root 5, or x is negative 8 minus root 5. So I do have two unique answers. They're just both irrational answers. Last one. Let's do x squared plus 12x plus 18 equals 0. So first things first, give ourselves some room for our perfect square. Move that 18 over to the other side. And then our perfect square, it is the middle number, 12, cut in half, and then squared. So 12 divided by 2 is 6, squared is 36. So our perfect number to add in is 36 to both sides. On my left, that middle number, cut it in half. We've got x plus 6 quantity squared. On the right, negative 18 plus 36 is 18. Take the square root of both sides. And when I take the square to that right side, I need a plus or minus sign. So on my left, I just have x plus 6. On my right, I have plus or minus the square root of 18. Let's pause here for a moment. This 18 can be simplified. 18 is 9 times 2. So I can pull a 3 out. So this is equal to positive or negative 3 root 2. And that's what I'll mess with to subtract 6 from. So I've got x equals negative 6 plus or minus 3 root 2. So we want to simplify at the end if we can. All right, we will leave it there. Next time we talk about vertex form, we will actually look for the vertex and graph from there. But we will leave these notes as is, and I will see you guys next time.